good afternoon to you, Doctor. My name is Eilliyah Fong, metric number 300157, and for my group's final Java project, we developed a program called Meal Recommender and Calorie Tracker. So it allows users to input their profile, track their meals, and receive meal recommendations based on their caloric needs. Most importantly, we applied two core data structures from our lessons, a custom linked list and a custom queue, to manage the data behind this system. So let me just give you a quick overview of how our code is structured and where the data structure concepts are applied. So firstly, we import Java libraries to create the GUI, to handle the layout, to listen to user actions, and store default menus using HashMap. So this is our own node class, a fundamental part of both our linked list and queue. It holds data and a pointer to the next node. This, we implemented our own myLinkedList class for dynamic meal storage. So my groupmate will explain this in her part. For my part, I will be explaining the queue that I'll be focusing on. So it uses custom linked list internally. So we add items using enqueue and remove them using dequeue, creating a first in, first out FIFO meal suggestion system. So this helps reinforce how queues behave under the hood using manual node connections rather than built-in Java structures. So let's take a look at the program in action. I'm going to click run. So first you'll have a pop-up saying welcome to Calorie Tracker and Meal Recommender. Please input your details to get started. So this, let me just put my info, I'm Eilliyah, my age. Okay, we have a scrolling menu, scrolling pane, binary female. This actually helps reduce human errors, such as if they input non-viable details inside. So this genuinely reduces a lot of errors, and it's very easy to use, very counterintuitive, so just like to maintain. So before I click into calculate TDEE, let me just show you our TDEE formula, which is around here. TDEE, yeah, so this one. So once I click calculate button, it'll actually enter this formula here. So TDEE is calculated using BMR. BMR is calculated this one, depending on the gender, and the formulas are not random. For example, in our TDEE, 1.2 is for sedentary, 1.55 is for moderate, and 1.725 is for active. So this is actually the activity multipliers from early metabolic research coming from Harris-Benedict and Mifflin-St. George's equation. So if the goal of the user is to lose, we will minus 500, and if the goal is to gain is it will plus 500. So where does this 500 come from? It comes from the Wish-Nofsky rule, which is notable. It's used in many medical websites such as WebMD, so they all adopt this as a safe guideline generally. And then let's say we go in here and then we say we wanna lose weight. So I calculate TDEE, and you can see that the meal panel set to true, so we will have our meal panel here. Okay, so let me just add a few ready meals. White rice, I don't know the calories. This one is pretty useful because, like, let's say you just want to be fast. For demo purposes, we only have a few selections, but in real life it will be much more. So once I click done, you will see a pop-up. You still need 406 calories, and what you have boiled egg, your recommended meal toast with peanut butter, yogurt, and a fruit cup. So what happens here is the system is actually using queue. So let me show you. If let's say I delete this one, okay, and then I say done, and you can see there's a chicken rice here. So this is actually the queue in action. So it's actually here. Yeah, so my queue recommended, my meal recommended. So here I include 5 recommended meals, Then I dequeue one by one, only showing meals that still fit within the user's remaining calories. So this is a clear example of FIFO behavior, first in, first out. The first suggested meal is also the first shown. So what's important here is that this queue is built using our own linked list, which means we manually manage node traversal and memory, not just using Java's ready-made collections. So using a queue for meal suggestions makes sense because meal suggestions should be offered in a fixed, predictable order. So this matches real-world logic, and it's a great way to apply the abstract queue concept to a real program. So through this, we learned how to implement queue operations manually, deal with null pointers, and manage size checks just like in our data structured class. So to recap, I covered the profile input, TDE calculation, and how to use a queue to suggest meals. So next, my groupmate will show how meals are added, updated, deleted, and stored using our custom linked list, which powers the rest of the application.
Hi, my name is Khairun Binti Zulkarnain. My metric number 293361. Now, let's jump into the application demonstration. First, I will show you how to add meals. As you can see, I have meal name and calorie field where I can enter a meal, for example, chicken salad with 350 calories. When I press the add meal button, this meal is added to the list and the total calorie is updated. Next, let me show how to update a meal. If I want to update the meal chicken salad to a chicken wrap with 400 calories, I can select it from the list, modify the details, and click update selected. This ensures the calorie count is recalculated accordingly. Now, if I want to delete a meal, I just select the meal from the list and click the delete selected button. This will remove the meal from both the list and the internal data structure, and the total calorie update accordingly. For linked list implementation, the meal data is stored in a linked list for efficient management. Each meal object contains the meal name and its calorie value. The linked list allow for quick addition and removal of meals, which make the system responsive while handling meals dynamically. For example, when meals are added or deleted, the linked list structure ensure minimal performance impact. Additionally, meals are stored in a queue to represent a chronological order of the meal added, which may be helpful for future meal tracking or viewing in sequence. For meal recommendation, after adding the meals and calculate the TDEE, the system recommend meals based on the remaining calories. If the total calories fall within a certain range, the application provides meals recommendation. For example, if the user has a lot of calorie left, it will suggest heavy meals like nasi lemak, fried chicken, teh tarik. In conclusion, the meals recommender system successfully allow user to add, update, delete, view, giving full control over their meal tracking, display meal information dynamically using linked list and queue data structure, receive personalized meal recommendation based on their daily calorie needs. This project highlight the practical application of Java Swing components and OOP object-oriented programming principle to build a functional and interactive system. Thank you for your attention.